Welcome to my presentation, Area Under the Curve. Before we talk about area under the curve, we'll first talk about understanding what the curve is. Now, for a continuous variable in an extremely large population, the number of bars is very large and the height of the bars approach a smooth curve. This is often referred to as a density curve or the probability distribution. The most common density curve is the normal distribution curve, and that's what we're going to talk about in this presentation. Just a few things about understanding the area under the curve. Because the density curve of a normal distribution has a bell shape, it is more difficult to find areas. The total area under the curve is equal to 1. And we should also caution when working with a normal distribution, be careful to avoid confusion with z-scores and areas. There are several formats used for finding normal distribution areas. When it comes to a cumulative area from the left, you can find the probability area by using table A1, by using StatDisk, Minitab, Excel, and StatCrunch. Also, when finding an area between two boundaries, the calculator can be used in StatCrunch. Today, we have an example finding an area using table A2 in the book. Our example today is about a bone density test. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis, a disease causing bones to become more fragile and more likely to break. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. So a randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test score less than 1.27. So we have to find the area under the curve that represents a test score less than 1.27. Using table A2 in the book, we find the first two numbers, 1.2, on our chart. And then we'll come over here to the top and find in the hundredths place the 7. Bring it on down where they meet, we have 0.8980. So we can conclude that the probability that a randomly selected person has a bone density test result below 1.27 is 0.8980, shown as the shaded region. We can conclude that 89.9% of people have bone density levels below 1.27. In conclusion, because of the curve, it can be difficult finding areas of probability using a normal distribution curve. Don't be intimidated. You could use a table or technology to find the probability.